1:30 it is working, sir.
Okay,
But
actually,
the
wait.
rest
I
it's
just
not
want
working.
to share my this one, uh, my ERP. Okay, just a minute. Okay.
Mhm.
Is it visible?
Um, yes, sir.
Visible, right? Yes. See, this is 19 August. Okay, that we have taken a class regarding open channel flow introduction. Okay, so this video is nothing but our
Yes,
recorded
sir.
video. Okay, so here I have uploaded the attendance,
Okay,
and
sir.
then after your feedback, it seems like this. Then we can view the attendance and see here total number of students is 52. Present in the class is 22, I think. Okay, so percentage is 42.31. Okay, so you can see your attendance. That roll number 130 is marked present. 137 it's marked present. Okay, I think it's okay. What is the total number of students in your section? It's 52.
So there should be more, but I think the ones who come to classes more often are around 50 only.
Okay, actually, we have already informed about this one. You are unable to give rating. So let's see how they solve. But in my ERP, it seems like this. That total students is 52, present in class is 22. Because I think that roll number 81, okay, her registration is not done. So that's why it's not showing. So I think that problem is also working on it. So it may be clarified today, I think, about roll number 81. Okay. So that's why
Yes,
actual
sir.
present in the class is
Yeah.
23, not 22. That roll number 81 is not in the list. So that is why we couldn't make present that roll number 81 because it's not in there in this list. Okay. So that's why it's class present in the class is 22. Let's see. We have already informed them that the IT department about your issue. Let's see how they solve this problem. Okay.
Okay.
So your problem is you are unable to read the class, right?
Yes, sir. Yesterday I read it, and the one I did also is gone now.
Ah, okay. Let's see.
Sir, then there's just one more doubt. In that YouTube channel, sir, it's not given that time duration till which we can wait, sir. It
Actually, your voice
repeated
is
says
not coming
that
properly. See, your voice is not coming properly.
sir,
Now tell me what happened.
in the YouTube video,
Hmm.
one we were supposed to watch, in that it's not showing the hours we will have for waiting, no, sir. According to Rigorous Sir, he said that
Ah,
there's a total of 72 hours, 48 hours for the teacher to read and 48 hours for the teacher to update the attendance, and then the rest 24 hours for the students to give the rating, sir. But then
yes, yes.
the other teachers are saying that only 48 hours for rating. So which one is true, sir?
No, no. I think it's 72 hours for students, right? And 48 hours is
Yes,
for
sir.
faculty to upload. Okay. So those things we
Uh,
have already informed the IT department. Maybe some technical issue, I guess. Okay. So it will be sorted out very soon. Don't worry. Okay. And we also clarify about this thing. Okay. When we need to upload, because see, my link is it's open for 48 hours. Okay. Then for your side, I don't know. That I need to ask. Okay.
okay,
We will start today's class. So, do you have any doubts from the previous class? Or if you don't have any doubts, then we will continue. I think we are about to discuss about types of flow in last class. Then our meetings ended. So we will start from here in today's class. Say in our previous section, we have discussed about types of open channel. Okay, this is types of open channel, and here now we are discussing about what are the different types of open channel flow. Okay, so here we have steady flow, we have steady flow. So these things you have already studied in third semester, but still I'll give you an overview about this. Okay, see, suppose this is a river, okay, flowing from upstream to the downstream. Okay, suppose this is your upstream, and this is your downstream. Okay, see, yesterday in last class I have said, see, our natural river is a non-prismatic channel. As if you see this diagram, here your width of the river is less, here is more than this. Okay, so it's not uniform. So that's why we used to consider our natural river as a non-prismatic channel. So now what is steady flow? Suppose you consider this is a top view, okay? What I have drawn, this is a top view. Here RL is higher than here, okay? So that's why the water is flowing in this direction. Okay. So now what we are going to do, we are going to take a section here, first section. If you draw the cross section diagram of section 1, it will be somewhat look like this. Okay. And this is the level of water. Okay. If you draw the cross section at section 1, it looks like this. Okay. So
So,
now,
we
yes,
can't hear it clearly.
it's not visible. Am I audible, Tasi?
Yeah, you're audible now.
Am I audible now?
Yes, sir.
So today it's a little bit network issue. Okay, my network is little bit down.
Okay, sir.
And Tasib, please keep the record of attendance. Okay. Thank you.
Okay, sir.
So, okay, we will start from beginning. Okay, as my voice is not clear at the time. Okay. See, is my this is the PDF file is visible,
Yes, sir.
and what I have drawn
Yes, sir. It is visible.
is visible. Okay. See, here, this is our river. Okay, this is our river, and it's a top view. When you see from the top, it seems like that the water is flowing in that river. This part we have considered your upstream. Upstream means your RL. RL is higher than the other part. Okay. So where the RL is more, that is called upstream, and the downward portion is called downstream, where RL is less. Because we all know the water is always flowing from a higher elevation to the lower elevation. So that higher elevation we usually termed as upstream of the river. Okay, so it seems that the water always flows from upstream of the river to the downstream of the river. So that's why I give the direction of the flow from upstream to downstream. Okay, from upstream to downstream. Okay, so now I have taken one cross section at upstream. Okay, I've taken one cross section at upstream, and it's named as 1. Okay, so this is the top view. If you want to draw the cross section diagram at section 1, then it will be seems like this. Okay, as we don't have any defined shape, so it will be somewhat a irregular shape of a river. Okay, so now actually we are discussing about steady flow. So what is steady flow? In that section, now what we are going to do, we are going to measure discharge, velocity, and depth of flow. Okay, we are going to measure discharge, velocity, and depth of flow. Then in that same section, that is section 1, after some time, maybe 1 hour or half an hour, after some time, again we are going to measure the discharge, velocity, and depth of flow. Okay, understood now? What we do in that particular section 1, first we measure discharge, velocity, and depth of flow for that particular section 1, and then we will wait for another half an hour or 1 hour. Okay, then again after 1 hour, again we are going to measure at the same point or at the same section, we are going to measure discharge, velocity, and depth of flow. If both the parameters, or you can say flow parameters, discharge, velocity, and y are similar, or you can say same, then that flow we can say it's a steady flow. That means if the discharge before 1 hour and after 1 hour is same, and the velocity is also same, and the depth of flow is also same, then we can say the flow is steady flow. That means with respect to the time, our flow parameters remains constant. It's not changing, but at the particular section. Okay, understood? So here that's why it's written, when the flow parameters such as discharge, velocity, and depth do not change with time. Initially, at 0 time, we have measured discharge, velocity, and depth of flow. And after 1 hour, see, 1 hour is not the standard one. I just take any random value. Okay, it may be 15 minutes or half an hour or one day. It depends. Okay, the time interval is depends. But The thing is that after some time, or after 1 day or 1 hour, if the discharge remains same, or velocity remains same, or depth of flow is remains same, then we can say that the flow is steady flow. The flow in that open channel is a steady flow. If it's not same, if it's not same, then we can say this is a unsteady flow. It's not constant. The flow parameters changing with time. Then we can say the flow is unsteady flow. Okay. So this is your steady and unsteady flow. So that means in a section, if you measure all the four flow parameters, and then you, after some time, in the same section, if you measure again those flow parameters, and if you see those are same, then you can say it's a steady flow. If those parameters are not same, then you can say the flow is unsteady flow. Okay, this is the river. Okay. Now, now in that same river, we have considered section 1, and at the downstream end, we are going to consider another section, that is section number 2. Okay, okay. So in the same channel, previously we have considered one section. Now we are considering two sections. One is in upstream and one section is in downstream. And similarly, in first section, we are going to measure discharge, velocity, and depth of flow. Okay. See, don't worry how to measure discharge. We are going to discuss in the next topic. We are going to discuss how to measure velocity and depth of flow. That is also we are going to discuss how to measure depth of flow in an open channel or in a natural channel. Okay. So what we have to do in the first section, again we have to measure discharge, velocity, and depth of flow. That is flow parameters. Okay. Then again in section 2. So those are in section 1. Okay. Then again we measure discharge in section 2, velocity in section 2, and depth of flow in section 2. If this discharge velocity and depth of flow in section 1 is same as discharge velocity and depth of flow in section 2, then we can say the flow is uniform flow. Okay, that means suppose that this is a section 1 we have considered. This is a section 1 we have considered. If the discharge in section 1 is same as the discharge in section 2, then we can say the flow is uniform flow. Okay. So that's why it says when you measure the flow parameters, and then if you travel some distance, if you travel some distance and you again measure those flow parameters, and those flow parameters are similar to that of the first section, then we can say the flow is uniform flow. And if those parameters are not same, then we can say this flow is non-uniform flow. Okay. So your steady and unsteady is related to time. Okay. And your uniform and non-uniform is related to your space, or you can say in simple language it's distance. Okay. In a river, that natural river uniform flow is what you can say is very difficult to find uniform flow, because as the cross section is not same, and the bed of the channel is also depends on nature, or what type of bed you have. Maybe in a river we have several types of beds depending on the locations, so that uniform flow, it is next to impossible you can find here in a natural river. So this uniform flow you can find out in your man-made irrigation canal. So those man-made you can find out uniform flow, but if you consider natural river, we can always find non-uniform flow. Okay, so this is very important. Okay, when you go for any competitive exam, so these are the common questions: steady flow, unsteady flow, uniform flow, non-uniform flow. So always remember steady flow. If we in a particular section, if we measure the flow parameters, and after some time if we measure the same parameters in the same section and those are similar, then we can say similar means same. Okay, suppose in 0 minute if you measure the discharge as 10 meter cube per second, and after 1 hour if you measure discharge again and you find out that it's again 10 meter per second, then you can say the flow is steady flow. Okay, if it is changed to 20, then you can say it's not steady flow, it's a unsteady flow. And similarly for uniform flow, if you measure the discharge velocity and depth of flow at section 1, and then you travel some distance and you consider another section 2, and those parameters you are going to measure again for section 2, and if those parameters are same, then you can say this is the flow in the river is uniform flow. Or if those parameters are not same, then we can say the flow in that particular channel is non-uniform flow. Then again, see, when we know talking about or discussing about non-uniform flow, the non-uniform flow again divided into one is rapidly varied flow (RVF), one is gradually varied flow, and another one is spatially varied flow. Okay, so now we are going to discuss what is gradually varied flow, what is rapidly varied flow, or what is spatially varied flow. See, this is your uniform flow. If you see the first figure, this figure, see, this flow is constant. Suppose we have taken one section here, okay, so we calculated the depth of flow y1, we found at 2 meter, suppose. Okay, then we travel some distance, this is x, say about 100 meter. Okay, in the same channel, this is the bottom of the channel, this is your bottom of the channel. Then we are going to consider another section 2, and we measure y2 value here. Okay, and if it is same as 2 meter, then we can say this is a uniform flow. That's why it's written its depth of flow is constant. The next uniform flow is our gradually varied flow. Okay. If you have see, we have a video of laboratory video in your YouTube, okay, channel that edit you have. So there in the lab, what we did, we try to create a gradually varied flow. Okay, gradually varied flow and a rapidly varied flow. So what is gradually varied flow? Suppose here in the first figure, if you consider this is first and this is second figure. Okay, in first figure, if you see this flow is running constantly. Okay, and then if you obstruct the flow by installing a hump, or you can say dam, okay, any obstruction, it is called barrage, or sometimes you can call wire, sometimes you can call dam. Okay, so if you obstruct the flow, what happen? Our flow is trying to increase. Okay, the flow is trying to increase gradually. Means why it is called gradually? Suppose this y1 is, this is 2 meter, and if you this is 3 meter, this is 4 meter. Okay, so it's gradually increasing from 2 to 3, 3 to 4. Okay, so that's why it is called gradually varied flow. If this value varies from 2 to suddenly jump to 10, then we can say this is a rapidly varied flow. Both are non-uniform flow. Okay, so here why it is called gradually, it is says that it's changing like one change. Okay, we have 2 to 3, 3 to 4, 4 to 5, or you can say 3 to 5, 6, 7, means two interval or three interval. There should be some pattern. Okay, then we can say it's gradually varying. But if your suppose here your depth is 2 meter, and suddenly after some distance you can find that you have found that your depth is increased to your 12 meter, then we can say this is sudden change in your flow, depth of flow, sudden change in depth of flow, and that is your rapidly varied flow. Okay, rapidly varied flow, rapidly varied flow. So here see, when you install a hump in the upstream, when you install a hump, or you can say dam or barrage, so here you can see the flow is gradually varying. This phenomenon you can observe. Okay, when the flow is overflowing over the dam or the wire, when it strikes here, you can see the water after striking here, the water jump. Okay, when it starts falling here, because when you consider a dam, it is at a very high head. Okay, the height of the dam is near about, if you consider a small dam, it will be 64 meter. Okay, from 64 meter, from when the water flows and it strikes the ground, what happened? The water itself jump. Here the depth of flow is very less before the jump, and after the jump your depth of flow is very high. So this is called your rapidly varied flow, or you can say this phenomenon is called hydraulic jump, which is an example of rapidly varied flow. Okay, so this phenomenon we have already studied in lab, so I suggest you to go through those videos. Okay, we have as we have not installed them, we have installed a barrage. Okay, or you can say hump. Barrage and hump is same. Okay. So we have installed them and we have measured the values, how the GVF is varying, and then how in the downstream we can observe this hydraulic jump in the same channel. Okay. So in that channel is our rectangular channel, and the length of the channel is about 6 meter. That is in our hydraulic slab. Okay. So you kindly go through those videos for clear explanation. Okay. So it will be much clear to you when you watch those videos. So those are examples of your, again, if you see in figure 3, this is your sluice gate. Okay. See, when it is closed, this head is very high. If you consider this head is very high, head of water. Okay. This is the head of water. When as soon as you open, there is a jump you can observe. Jump is nothing but sudden change of depth of flow. Sudden change of depth of flow. See here you can see when as soon as you open the gate, as soon as you open the gate, the water is flowing at a very high velocity. Okay. So what happened? Once it's coming out, he got the space to increase its depth. Here, what happened? You have the sluice gate. Okay. As soon as it comes out, it got the space to increase its height. So after, if you see this phenomenon of in the irrigation system, we have sluice gate. Once we open the sluice gate, this phenomenon can absorb. Okay. This is another example of hydraulic jump, where we have two depth. One is before jump, y1, and one is after jump, y2. So this is another example of gradually varied flow. This is figure number 4. This is 5. Yeah, this is canal fall. So don't worry what is canal fall. You are going to study in irrigation subject. Okay. There is a chapter called canal fall. Okay. So you are going to study in details what is canal fall. But I just give you an overview when you have your difference in bed level. Suppose this is your bed level for canal, and because of the topography, we have to reduce, or if our surface is somewhat like this, then after cutting the whole area, what we do, we make the bed level over here, and then we will make a fall here, and then again will be the bed of the canal will be here. So because of this phenomenon, we can see gradually varied flow in that particular fall. So don't worry, those things you are going to discuss in details in irrigation subject. Okay. So next is spatially varied flow. This is nothing but we all know when we consider a river, when we consider a river, if you consider a river, we all know there are some tributaries, or it's, or let me see if I have a clear picture of tributaries, then it will be much. Uh, is it visible that map of study area?
Yes, sir.
Yes, sir. Okay. See, this is the project. Okay, we carried out last your senior batch carried out. Okay, so this is the area of Kulsi. Kulsi is combining two states. One is your Meghalaya, one is Assam. So the upstream of the Kulsi is in Meghalaya. Okay, and the downstream of the Kulsi is in Assam. Okay, and what happened because the Meghalaya is a hilly area, we have runoff and it's accumulated at the downstream end and it causes flood. Here you can see this is the lower elevation and here is the higher elevation. So if you see this color, dark color, it's a maroon, I think. Okay, that is your main Kulsi River. Okay, that is your main Kulsi River. And if you can see, those are lateral inflows. That blue lines you have seen, those are lateral inflows. Okay, those are lateral inflows. Or you can say, I think you have heard about sub basin. This is called basin. If you consider those lateral inflow as one outlet and you again delineate the basin, those are again your sub basin. Just wait for 1 minute. I will show you the sub basin also. Okay. Now it's visible. Sub basins. This is the study area. Okay. Here you can see this location, that yellow. This is the proposed site of Ukiam Dam site. Okay. This is the proposed Ukiam Dam site. So this is was proposed and the construction or approval is not yet. It's on process. Okay. So what we did in the last semester, we are have also one proposed here a small gravity dam. We designed that gram and then we find out the reservoir capacity. Okay, what will be the reservoir capacity for that particular dam? And then because of that pandemic situation, we couldn't complete this project by evaluating how much power it's going to generate. Okay, so those we because of the pandemic we couldn't complete the project. Okay, but we did rainfall runoff model you have already studied in hydrology. Okay, in hydrology subject, rainfall runoff model we have performed. Then we calculated design discharge. Then for the design discharge we have designed a dam. Okay, we did stability analysis of the dam, earthquake analysis. Then we calculated that reservoir capacity or how the reservoir or what will be the storage of the reservoir. Okay, and then we stopped. Okay, further we need to think about how to lay the how to divert the water and then powerhouse and all. Okay, so those are remaining because of we couldn't complete. Okay, because of this pandemic situation. Okay, so this is the thing. This is the outlet. If you see here, if you see here, this is the outlet of the whole Tulsi basin. Okay, here it's connected with river Brahmaputra. Okay, this is connected to the river Brahmaputra. This is your upstream. You can see this is your main Kulsi river. This is your main Kulsi river. Okay, this is your main Kulsi river, and those see blue lines. Those are your lateral flows. Those are your lateral flows. These are lateral flows. Okay, these are lateral flows. So when you Here, if you see here, this is called your specially varied flow with increasing discharge. Means if you have lateral inflows, that suppose first you have Q and then you have a lateral inflow of small q1, then your discharge will be Q plus Q1. It increasing. Okay. Then again you have another Q2 of lateral inflow. Then your total discharge will be Q plus Q1 plus Q2. Okay. So this is called your specially varied flow, or in reverse way also. It may decrease also. Okay. If you see here, if you see here, it may decrease also. Say initially you have Q, then Q1 is going out. So what will be discharge left out? Q minus Q1. Then again you have a discharge of Q2 is going out of the river. So that's why what will be the remaining discharge is Q minus Q1 minus Q2. You can write this like Q1 minus Q1 minus Q2 and so on. Okay. So these two are called specially varied flow with increasing discharge when it's coming lateral inflow, and when it's going out it's called decreasing discharge. Okay. So our meeting is going to end. Okay. So I think we have another class. So we will take 10 minutes break and we will start off at 11:15. Is it okay?
Yes, sir.
Okay. So we will again start a meeting at 11:15. I will give you the link, new link. Okay. Thank you.
Thank you, sir.
Or
Thank you,
if
sir.
you have any queries, or if you need to ask anything, any doubts, you can ask me now. See, is this subject is interesting
Yes, sir.
or nothing is interesting related to civil?
It's revision for
Online is
mostly
little bit
full
difficult.
modules.
So see, you people, if you understand, see, if you know what is steady flow, you need not to learn or you need not to memorize. You know, you can write of your own. So that's what in the very beginning class, I ask you just to understand what is going on, how it's happening. Okay, you can easily relate with other things, and you can write of your own once you understand. Not that much difficult. Anyways, what is the number of participants? 39. Okay.
Sir, it was 40 earlier. I just,
Tasi, hello.
it was 40, sir. 40. It's not only this week, 39.
Tasi, can you text me? Actually, your voice is not coming.